Attention car shoppers. Right now at South Carolina Federal Credit Union, you can get a new or used auto loan and pay nothing until 2024, and no payments for 90 days means nothing out of pocket going into the new year. Plus, we have flexible rates and terms, so you could make the best financial choice for you. Learn more at scfederal.org/autoloans. That's scfederal.org/autoloans. Certain restrictions apply. Existing South Carolina federal credit loans are excluded.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 25, Episode 102, for broadcast on the 20th September 2022. Coming up on SpaceTime, the James Webb Space Telescope develops a serious technical problem, but that hasn't stopped it from making some spectacular observations of Mars and Neptune. And it's now 200 years since the opening of Australia's first astronomical observatory. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's James Webb Space Telescope has developed the problem with a key part of its spectroscopic system used to analyse the chemical composition of objects. The issue centres on the mid-infrared instrument's grating wheel, used to allow scientists to choose the wavelength of light they want to focus on. The wheel is used in the medium-resolution spectroscopy mode, during which the camera gathers different wavelengths of light, called spectra, which act like chemical fingerprints to identify different elements and molecules. Launched in December and beginning scientific observations just a few months ago, James Webb is the largest and most powerful space telescope ever built. Mission managers first detected the problem back in August and have now decided to pause observations with the affected mode so they can come up with a workaround. NASA says the $10 billion Earth-orbiting observatory is otherwise in good health, and the mid-infrared instrument's other three observing modes, imaging, low-resolution spectroscopy, and coronagraphy, are all operating nominally and remain available for scientific observations. The mid-infrared instrument is one of 4 primary science instruments aboard the telescope capable of taking both images and light spectra of distant objects across the universe. Unlike the Hubble Space Telescope, which is in low Earth orbit just 520 kilometres above the ground and which could be fixed during regular Space Shuttle service missions, the James Webb Space Telescope is orbiting some 1.6 million kilometres away from the Earth on the dark side of the planet and well beyond the reach of existing manned spacecraft. This is SpaceTime. Still to come, James Webb may have a glitch, but that hasn't stopped it taking some spectacular observations of Mars and the planet Neptune. And this year marks 200 years since the construction of Australia's first astronomical observatory. All that and more still to come on SpaceTime. Well, NASA's James Webb Space Telescope may be suffering a bit of a glitch right now, but that hasn't stopped it capturing some spectacular images and spectra of the red planet Mars and the distant ice giant Neptune. The sensitivity of the giant infrared telescope has provided scientists with unique perspectives of the Martian surface, complementing data being collected by orbiters, rovers, and other telescopes. As a result, James Webb can capture images and spectra with the spectral resolution needed to study short-term phenomena like dust storms, weather patterns, seasonal changes, and in a single observation, processes that occur at different times of the day. But there are issues. Because it's so close, Mars is actually one of the brightest objects in the night sky in terms of both visible light, which human eyes can see, and infrared light, which James Webb's designed to look at. This poses special challenges to the observatory, which was built to detect extremely faint light from the most distant galaxies in the universe. In fact, Webb's instruments are so sensitive that without special observing techniques, the bright infrared light from Mars is blinding, causing a phenomenon known as detector saturation. Astronomers adjusted for Mars's extreme brightness by using very short exposures, measuring only some of the light that hit the detectors and then applying special data analysis techniques. Webb's first images of Mars, captured by the near-infrared camera, show a region of the planet's eastern hemisphere at different wavelengths or colours of infrared light. The brightness of the light is related to the temperature of the surface and the atmosphere. The brightest regions of the planet is the area where it's warmest. That's because that's where the sun is almost directly overhead. These brightest areas are dominated by reflected direct sunlight, and the revealing surface details similar to those apparent in visible light images. These include the rings of Huygens crater, the dark volcanic rock in Syrtis Major, and the brightening in the Hellas Basin. In areas where the sun's light is more at an angle, James Webb sees thermal emission, light given off by the planet as it loses heat. And the brightness continues to decrease towards the polar regions, which obviously receive less sunlight, and even less light is emitted from the cooler northern hemisphere, which this time of year experiences its Martian winter. However, temperature isn't the only factor affecting the amount of light reaching James Webb. As light emitted by the planet passes through the Martian atmosphere, some of it gets absorbed by carbon dioxide molecules. The Hellas Basin is the largest well-preserved impact structure on Mars, spanning more than 2,000 kilometres, and it appears darker than the surrounding area because of this effect. But the effect isn't thermal. See, the Hellas Basin is at a lower altitude and thus experiences slightly more air pressure. And that higher pressure leads to a suppression of the thermal emission at the telescope's specific wavelength range because of an effect called pressure broadening. Whereas the images of Mars are showing differences in brightness integrated over a large number of wavelengths from place to place across the planet at specific times of the day, the planet's spectrum is showing subtle variations in brightness between hundreds of different wavelengths, which are representative of the planet as a whole. The infrared spectrum was obtained by combining measurements from all 6 of the higher resolution spectroscopy modes of James Webb's near-infrared spectrograph. Preliminary analysis of the spectra show a rich set of features that contain information about dust, icy clouds, what kinds of rocks are on the planet's surface, and even the composition of the atmosphere. The spectral signatures include deep valleys known as absorption features and highlight water, carbon dioxide, and carbon monoxide. Meanwhile, spectacular new James Webb images of the solar system's most distant planet, Neptune, have also been captured for the first time. The new images, taken by observations using the near-infrared camera, are displaying the ice giant's rings in stunning, never-before-seen detail. Astronomers say they're the clearest look at Neptune's rings since NASA's Voyager 2 became the first spacecraft to visit Neptune during a flyby back in 1979. And it's the first time the rings have been seen in infrared light. As well as Neptune's ring system, its dust bands are also clearly visible in the new images. But one of the most striking features were 7 of the planet's 14 known moons, including a spectacular Triton, which appears to far outshine Neptune itself. That's because instead of its usual royal blue colour, Neptune's methane gas atmosphere absorbs red and infrared light so strongly that it appears to be quite dark in near-infrared wavelengths, except for the high-altitude methane ice clouds, which appear as prominent bright streaks and spots, reflecting the distant sunlight before it's absorbed by methane gas. Meanwhile, Triton seems to shine like a diamond because it reflects an average of 70% of the sunlight that hits it. The giant moon orbits Neptune in retrograde, that is backwards, and that's because it's suspected to have originally been a Kuiper Belt object like Pluto and Charon, but ventured too close and was gravitationally captured by Neptune. This is SpaceTime. Still to come, we celebrate 200 years since the opening of Australia's first major astronomical observatory, and later in the Science Report, a new study warns that TikTok is providing false and misleading information to users searching for news and factual information. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, NordVPN. You know, I don't have to tell you that when it comes to online security and privacy, NordVPN really is the best in the business. And at times like these, that's exactly what you need. They've got the fastest servers, they've got the best encryption, and they'll protect up to 6 of your devices at the same time. And that includes your smart TV, something a lot of people these days overlook when assessing their online security needs. And while we're talking about things overlooked, don't forget your router. NordVPN will protect that as well. So you get great security, great service, a 30-day money-back guarantee, and speed. What more could you want? Well, there is more, namely a great deal for our SpaceTime listeners. If you go to our special URL, nordvpn.com/StuartGary, we'll give you an incredible 4 months free with all plans and up to a 69% discount on any 2-year plan. Now, there are multiple plans available, one to suit every budget, but I can assure you the complete security package will see all your needs covered in the one plan. Here's what the package includes. There's malware protection, there's a great secure high-speed VPN service, a password manager, a terabyte of secure online storage, a tracker and ad blocker, a data breach scanner. And of course, it all comes with that 30-day money-back guarantee, so you've really got nothing to lose. Why not give it a try? When it comes to online security, you really do need to take the threat seriously. So head over now to nordvpn.com/StuartGary and grab one of our great deals. And of course, you can also use the coupon code StuartGary when signing up to get the deal. And of course, the URL details will be in the show notes and on our website. And now, it's back to our show.
This is SpaceTime with Stuart Gary.
This year marks the 200th anniversary of Australia's first major astronomical observatory, which was built in what is now Parramatta Park in Sydney's western suburbs. It was constructed just 34 years after the establishment of the colony in the gardens of Old Government House by the Governor of the British Imperial Colony of New South Wales, Lieutenant General Sir Thomas Brisbane, and operated by astronomers Carl Rumke and James Dunlop. The twin-dome structure was built out of wood and canvas. Today, only the transit piers and a solitary marble obelisk remain. But during its heyday, Parramatta Observatory produced many important discoveries and observations of the then poorly explored southern skies. Its primary mission was to produce a usable catalogue of star positions in the southern skies, eventually mapping some 7,385 stars, a substantial achievement which supplemented the South African catalogue of 1752 to 53. Its telescopes also observed at least 2 comets, numerous transits, and multiple binary star systems. However, the location of the observatory proved to be a poor choice, with local populations growing quickly and smoke from home fires at night making observing less than ideal. Over time, the building lacked the maintenance needed to remain operational, and in 1847 it was dismantled, with its instruments and documentation reused for the Sydney Observatory, which was opened in 1858. Nick Lom, consultant curator of astronomy with the Powerhouse Museum Sydney Observatory, says the Parramatta Observatory's bicentennial is one of 2 major Australian astronomical anniversaries this year, the other involving no less a figure than Albert Einstein.
There are 2 major anniversaries this year. One relates to the Parramatta Observatory. This was the first major observatory set up in Australia. There was one, a very small one, set up by Lieutenant William Dawes, who came out with the first day. But the Parramatta Observatory was the first major firmament observatory. This was set up by Sir Thomas Brisbane, who arrived in November 1821, and he built an observatory at a Government House in Parramatta, and that was the timber observatory with 2 domes, and that was completed on the 2nd of May in 1822. So it's the bicentenary of that observatory. So that's quite a major event. And just a month later, they made a major discovery. The 2 astronomers helping Brisbane, James Dunlop and Carl Rumke, German astronomer, rediscovered Encke's comet. And this was the 2nd comet whose return to be predicted was actually seen. And it was not seen in Europe in 1822, it was not just seen in South Africa, but Dunlop and Rumke managed to see it in June 1822. And that really created lots of excitement among European astronomers and really put Australian astronomy and Parramatta Observatory onto an international map. So that was one anniversary for a centenary. There's also a centenary of an eclipse, the Einstein eclipse, 21st of September 1922. Albert Einstein published his general theory of relativity, 1916, and one of its main predictions was that passing starlight passing near the sun would be bent by a tiny amount, 1 3/4 seconds apart. A very tiny amount. The only obvious way of measuring it is during the total eclipse of the sun, because other times the sun is too bright to look at and too bright to look at stars right next to it. But it came out in 1916. 3 years later, there was an eclipse in 1919, and the British government or British astronomers put a lot of effort into observing it. And the expedition to Brazil, to an island off the coast of West Africa, and they tried to measure the deviation, this bending of starlight, and they got an indication that it is true, but their results weren't conclusive. But it was left to the 1922 eclipse in Australia, visible from Australia, to make a definite assessment where this deviation does happen. And there were lots of expeditions in Australia to try and observe the eclipse. There was an observatory expedition to Kundavindi, but the successful one was on Nick Observatory. They went to a place called Balal in Western Australia near Broome, and they made observations which finally made a very definite proof that the bending did happen, and it was the first real proof the general theory of relativity. I mean, the people have been testing ever since for the last 100 years, and so far it has passed every single test that has been thrown at it.
That's Dr. Nick Lom, Consultant Curator of Astronomy at the Powerhouse Museum's Sydney Observatory. A Russian capsule carrying 2 Russian cosmonauts and an American astronaut has successfully docked to the International Space Station 3.5 hours after launching aboard a Soyuz 2-1A rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan.
And we are now back live. Soyuz MS-22 rocket on the launch pad at Site 31 at the Baikonur Cosmodrome in Kazakhstan. Atop the 2.1A booster strapped into their seats in the descent module of the Soyuz, NASA's Frank Rubio, along with Sergei Prokopyev and Dmitry Petelin of Roscosmos. At the time of launch, the International Space Station will be flying over northwest Uzbekistan. The station and the Expedition 67 crew will pass directly over the Baikonur Cosmodrome 1 minute, 58 seconds after launch, and will leapfrog past the ascending Soyuz vehicle as it heads to orbit. 8 minutes and 45 seconds after launch, the third stage engine of the Soyuz booster will shut down, and the Soyuz will separate from its launch vehicle in a preliminary orbit, deploying its solar arrays and its navigational antennas. At that point, the 3 crew members will be trailing the space station by about 1,000 miles. The chase will begin, resulting in a docking to the Rassvet module of the International Space Station at 12:11 p.m. Central Time. All of the launch preparations have gone off without a hitch. Everything is in readiness.
15-3, this is Altai 1, visors are closed, rescue aids are ready.
At this point in the countdown, the Soyuz's first and second stage engines are ready for launch, telemetry having been received from the rocket, indicating that all primary and backup systems are set to support liftoff. Once again, at the time of launch, the International Space Station will be flying 259 miles over northern Uzbekistan, some 335 statute miles behind the Soyuz as it leaves the launch pad. A very narrow phase angle for launch for orbital insertion that will ensure the beginning of a 2-orbit, 3+ hour rendezvous to reach the International Space Station. And during the Soyuz climb to orbit, the ISS will leapfrog ahead of Soyuz, and Soyuz will then be catching up to the International Space Station through a series of pre-programmed rendezvous burns.
Everything is nominal on board. We are ready for launch.
Sergei Prokopyev, the Soyuz commander, reporting back to launch controllers in Baikonur that everything is in readiness aboard the Soyuz MS-22 spacecraft. The 2 umbilical towers that are buttressed up against the Soyuz, the first will retract at about the T-minus 30 or 35 second mark. The second of those 2 umbilicals will retract at about the 12-second mark before launch, initiating the auto sequence start for engine ignition and ultimately for liftoff. A launch key has been inserted in the launch bunker. This is a real key that transitions the launch sequence into automatic mode. And launch controllers down at Baikonur reporting that the range is clear. The Soyuz rocket ready to begin its journey.
Launch key inserted.
The three crew members strapped into their seats in the center section, the descent module, have closed their visors for launch. Sergei Prokopyev reporting that everything is in readiness on board the Soyuz. Onboard systems will be switching to onboard control. The commander's cockpit displays now activated. Strip chart recorders in the Launch Control Center now activated. They will be recording telemetry from the launch vehicle during liftoff and its climb to orbit. The sun setting on the Central Asian desert, everything in readiness for launch at 8:54 and 49 seconds a.m. Central Time, 6:54 and 49 seconds p.m. Baikonur time. The Soyuz 2.1A booster fuel lines and other elements of the rocket engines now being purged with nitrogen to fireproof them to remove vapors of fuel and oxidizer for the final minutes of the countdown. Moments from now, a key will be placed in the drainage position. The valves through which evaporated or gaseous oxygen escapes from the fuel tanks into the atmosphere are closed as the fuel begins to drain back into the tanks. At the same time, the valves providing liquid oxygen to replenish those tanks will be lost by the natural boil-off or evaporation. The fuel and oxidizer tanks now being pressurized to optimize fuel flow to provide additional structural rigidity to the launch vehicle on the pad.
Booster propellant tank pressurization initiated.
Tank pressurization underway. Everything in good shape.
Vehicle is nominal. Copy.
Coming up on the termination of the ground propellant feed to the Soyuz booster. The Soyuz about to go on internal power.
Vehicle switched to internal power. First umbilical tower separation.
First umbilical should be retracting, and there it goes. The second umbilical will retract at about the T-minus 15 second mark.
Auto sequence.
The second umbilical has retracted. This will initiate the auto sequence start. T-minus 10 seconds and counting.
For ignition.
We have engine start.
Second umbilical tower separation.
Turbo pumps coming up to flight speed.
Turbo pumps, flight speed,
and liftoff. A sunset start to the mission of Rubio, Prokopyev, and Patelin to the International Space Station.
10 seconds. Flight is nominal.
Good first stage performance reported from the blockhouse at Baikonur. The Soyuz delivering 930,000 pounds of thrust from its four boosters and single engine.
L plus 20, L plus 20.
Arcing out to the northeast from the Baikonur Cosmodrome.
Rating nominally.
Everything looking good so far. Good roll, pitch, and yaw program. Vehicle reported structural stability is good.
It's feeling well. Vehicle is nominal. Copy.
Velocity now about 1,100 miles per hour. Yaw, pitch, and roll program all reported to be nominal from the blockhouse at Baikonur.
Nominal. Vehicle is nominal. Crew is feeling well.
Prokopyev reporting the crew is feeling well. Now passing through the area of maximum dynamic pressure.
L plus 80 parameters are nominal. Pressure in KPO parameter is above nominal. Copy KPO parameter of nominal. Correct? Affirmative. Sat jettison confirmed.
And we've had first stage separation.
Nominal. Crew is feeling well. KPO pressure parameter is nominal. Copy. KPO is nominal. Please report pressure. 834. Second stage engine operating nominally.
Launch shroud now has been jettisoned.
Vehicle is nominal.
The Soyuz booster about 48 miles in altitude, traveling about 5,200 miles an hour, some 72 miles downrange.
L plus 190.
3 minutes, 20 seconds into the flight.
C indication controlled descent available. Vehicle is nominal. Copy. Indication is on.
All good reports so far. The flight reported as nominal as we approach the 4-minute mark into the flight.
Pressure reached 105,1500 for a moment. Copy.
Second stage engine continues to burn as planned as we approach the 4-minute, 15-second mark mark into the flight. About halfway through powered flight now.
Copy.
About 15 seconds away from second stage shutdown and the ignition of the third stage.
L plus 270, parameters are nominal. Second stage separation confirmed.
Second stage shutdown and separation is confirmed. The Soyuz now climbing to orbit on the singular power of its third stage engine. 5 minutes, 12 seconds into the flight, about 3.5 minutes of powered flight remaining.
L plus 310, launch vehicle is stable. Vehicle is nominal, crew is feeling well.
Prokopiev reports that the crew is doing well. This third stage engine providing 67,000 pounds of thrust for the remaining 3 minutes of powered flight.
350.
A true trajectory so far for the Soyuz booster, now flying on the third stage propulsion of its singular engine. Good roll, pitch, and yaw reported. Good structural stability reported.
380 seconds, the engine of the third phase is working nominally. 400 seconds, the stabilization of the article is in place. It is stable. Altai.
Good structural stability of the Soyuz vehicle at the 7-minute mark into the flight, about 1 minute, 45 seconds of powered flight remaining. Yaw, pitch, and roll all reported to be nominal. At the time of third stage shutdown and spacecraft separation, control of the Soyuz vehicle through docking will transition to the flight control team at the Russian Mission Control Center outside of Moscow.
Nominal crew is feeling great.
We have now reached the 8-minute mark into the flight, 45 seconds away from third stage shutdown and spacecraft separation.
480, the parameters of the launcher is nominal, and everything is nominal on orbit, and the crew is feeling great. We're waiting for the separation. 520.
And we have third stage shutdown and spacecraft separation, the third stage dropping away. Time tag commands now will deploy the solar arrays and the navigational antennas.
Altai, Moscow. Altai, Moscow.
And we now have confirmation of a perfect solar array and navigational antenna deploy. The Soyuz MS-22 now in its preliminary orbit, and the chase has begun to catch up to the International Space Station with docking planned just 3 hours from now after a 2-orbit journey. Docking scheduled at 12:11 p.m. Central Time.
The flight came as Russian President Vladimir Putin threatened the world with nuclear war if NATO interferes with Russia's bloody invasion of Ukraine. The Soyuz MS-22 docked with the space station's Russian Razvet research module after just 2 orbits of the planet. The crew will spend 188 days in orbit before returning to Earth next March. It's one of the few examples left of Western cooperation with Moscow and demonstrates the need for continued cooperation between the Russian Federal Space Agency Roscosmos and NASA involving the jointly run space station, despite unprecedented sanctions against Russia and more evidence of war crimes being committed against Ukraine's civilian population. And this rare example of cooperation will continue next month when a Russian cosmonaut will fly up to the space station with a NASA crew aboard a SpaceX Dragon capsule. The Russian cosmonauts and Western astronauts working together in orbit have tried to steer clear of the conflict raging down on the Earth below. The International Space Station is divided into separate US and Russian orbital segments, with the Russians providing propulsion and the Americans providing auxiliary power and life support. This division of resources forces both sides to work together. The other partners in the space station are Canada, Japan, and the European Space Agency, and they all share the American segment. Moscow says it plans to leave the space station sometime after 2024, when the first module of its new Russian space station enters orbit. It's not known how much, if any, of the Russian segment of the space station they'll take with them when they go. But we'll keep you informed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The United States is looking at a plan to increase its own capacity to build nuclear submarines so that it can fast-track the construction of the first Australian nuclear subs, while Australia builds up its own nuclear submarine construction capabilities. In return, Australia would pay towards the increased American construction capacity. The move would see the first 2 or 3 Australian nuclear submarines built in the United States, with the remainder of the 8 to 12 sub fleet then built locally at Adelaide. If approved, the move would allow the Australian Navy to begin operating its own nuclear submarine fleet by the middle of the 2030s, cutting 10 years off production lead-in times. The proposed plan, which is yet to be formally approved, is part of a joint response by Washington, Canberra and London to the growing threat being posed by China's rapid military build-up in the Asia-Pacific theatre. The joint Australian, British and American alliance will see the sharing of technologies and capabilities between the three nations involving not just nuclear subs, but also artificial intelligence, autonomous systems, hypersonic missile development and technology, and undersea technologies. Last month, the US Navy warned that adding Australian submarines to the production line building America's new Columbia-class ballistic missile submarines without increasing construction capacity would seriously interfere with the American efforts to build up its own subs. Expanding the US capacity is being seen as the best option to expedite the initiative, as British shipyards have their own hands full right now, building 7 Astute-class attack subs and 4 Dreadnought ballistic missile submarines. Northrop Grumman has unveiled Australia's first high-altitude long-range Triton MQ-4C autonomous aircraft. Developed for the Australian Air Force and US Navy, the Triton follows on from the earlier RQ-4 Global Hawk, which was deployed by the US Air Force, NATO and NASA, with the German Luftwaffe purchasing a single test version they called the Eurohawk. The main differences between the new Triton and the earlier Global Hawk focus on updated electronics and a different wing design. You see, while the Global Hawk's designed to remain at high altitude to conduct surveillance, the Triton climbs to 55,000 feet or 1,700 metres to see over a wide area and then quickly drop down to 10,000 feet or 3,000 metres in order to further identify a target. So Triton's wings are specifically designed to take the added stresses of rapidly decreasing altitude. Australia's Tritons will operate alongside their P-8A Poseidon maritime surveillance aircraft counterparts. As partners, the United States and Australian Defence Forces will share data collected by their respective Tritons in what's become one of the world's most strategically important regions. The aircraft is scheduled for production completion in 2023, with delivery the following year. Canberra was also set to purchase a squadron of MQ-9 Reaper drone aircraft based on the highly successful MQ-1 Predator. However, that order was quietly cancelled by the Morrison government in March, just prior to the federal election. There's been yet another warning about the effects of climate change, with a new study showing that Australian reef fish populations are now being dominated by generalist species rather than specialist species which are adapted for specific habitats or niches. The findings, reported in the journal Current Biology, show that temperature and habitat changes are causing significant disruptions to Australian reef fishes. The study's authors say that the effects of habitat change, like coral bleaching and temperature change, is having varying impacts depending on the reef's location, with fishes on temperate and subtropical reefs appearing to show more signs of temperature change, while the tropical reef fishes seem to be more affected by habitat change. Scientists say that during the 2011 marine heatwave, which warmed waters in southwestern Australia, temperate reefs saw an influx of tropical fishes that kept hanging around for years after the event. A new report warns that TikTok is providing false and misleading information to users searching for news and factual data. The warning by the media watchdog NewsGuard says toxic and false claims published by TikTok represent a significant threat as the platform becomes a go-to online venue for young people looking for information. NewsGuard analysed the top 20 results from 27 TikTok searches on news topics including school shootings, abortion, COVID-19, US elections, and Russia's war on Ukraine. They found 19.5% of the data contained false or misleading claims and information. They say even when TikTok search results yielded little or no information, the results were often more polarizing than Google's and included false or misleading claims and conspiracy theories promoted by groups such as QAnon. Well, they only released it last week, but Apple have already been forced to begin fixing a whole bunch of issues with their new iOS 16 update. So what's gone wrong? Well, Apple iOS 16 was full of bugs, and iOS 16.01 was limited to iPhone 14 models. So this new update, iOS 16.02, is the first dedicated fix for all iPhone owners. However, the problem is it's still causing as many problems as it fixes. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
For a while, there were various problems that always exist when you're upgrading to a new operating system. I was trying to use Foxtel Go, a streaming service, and when you've got the phone in portrait mode, the image looks fine. But if you try and put the phone in landscape, horizontally, the picture sort of shifts off the screen. You only see a corner of it. And to get around that, you have to lock the phone in portrait mode and then open up the app, tap the button to make it go in landscape, and that fixes it. But then if you push the button to put it back into portrait mode, it shifts the image again. So little fixes like that, some of those need to be taken care of by the app makers themselves. But there was reports that the iPhone loses a lot of battery in the first sort of 48 hours or so. And in fact, that normally happens whenever you put a brand new 0.0 update, because the phone is re-indexing itself and checking things, and you get lower battery life for the first couple of days, but then it should even out again. If you're having problems, continued problems with that, then make sure you go to the Genius Bar at an Apple store and get it to check. But otherwise, give it a week or something, and you should find that your battery life goes back to normal. Although, obviously, some people might have batteries that are down to the 80% level where they're really starting to lose power earlier. So you can check the battery health in the settings as well. A worrying bug was where people's camera system inside the phone, the optical image stabilizer, started to shake violently and give this horrible grinding noise. And that is a problem that happened not with Apple's camera, but with third-party cameras from Instagram and WhatsApp and others. And the suggestion is that those software makers were using private APIs, private ways of controlling the Apple camera that aren't sanctioned by Apple. And so there's been some issue there, which you can see videos online if you do a search for it. One of the issues is the battery indicator. So at the moment, the battery indicator has finally got a percentage in it if you enable that in the settings. But whether the battery is 50% or 100% or 21%, it's showing you that the battery looks like it's full with a number that might be 21. Now, when it gets to 20, it's telling you, obviously, that you have low power. You might want to put on low power mode. But in this update, the battery indicator will slowly go down and down like it normally does. It'll be white showing you how much power you have, but the bit that is shrinking down gets grey, and the numbers will change colour accordingly, which is how it's done on most Android devices that do something similar. So they fixed up the battery indicator, which is very cool. Another thing that people are unhappy about is that your phone is now asking you every time you want to paste from one app to another. It's like, hey, Safari wants to paste something into your email or wherever it might be. And for some people, this message is coming up all the time, every time they paste, every single time. And it harks back to when Apple was making fun of Microsoft for Windows Vista having the cancel or allow question, so that everything you did, you would ask to cancel or allow. And this sort of seems reminiscent of that. And the final thing that is in the iPhone OS that's coming is that if you're in the US, you can charge by greener energy sources like wind, solar, and hydro. That's US first to start with, but it should come to other parts of the world over time.
So that means what? It just knows when it's charging from different electricity sources?
This is where the Apple is telling your device that, hey, the grid in your area is being powered largely or entirely by energy from solar, wind, and hydro sources. And so the iPhone can delay charging until it's getting energy, which is supposed to come from those more renewable areas. That's something actually that Microsoft's Windows 11 update, their biggest update in a year, is supposed to be now enabling, but again, only in the US. Obviously, some information needs to be sent to Apple or to Microsoft for when the grid is meant to be being powered by those renewable sources.
A bit like an off-peak signal for the old-fashioned hot water heaters.
Yeah, that's right. But a bit like an off-peak to say, if you want to charge in a more environmentally friendly way, just give your phone authorization to charge now or in 2 hours. So it's quite a clever thing because we do have problems with the grid. It's able to have a lot of green energy.
Well, you're in San Francisco right now, so I'm surprised you have electricity.
Well, that's one of the things. You need to have reliable baseload power. the human race has an issue that we want to do too much too fast with too little. We want the technology we have today to be giving us warp 9 speeds in space and teleportation, and yet we can barely get off the planet.
That's Alex Zaharov-Reut from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.